Alright, good morning class. Alright, so today what we're learning about is Pythagorean Theorem. And this has to do with right triangles. So start writing this down on your worksheet underneath Pythagorean Theorem. And this is how this works. This is a way for us to figure out in a right triangle one of the side lengths. So this is how we find it. If there is a right triangle, then we do a squared plus b squared is equal to c squared. Or the other way that you could think about it is leg squared plus leg squared is equal to your hypotenuse squared. And if you're wondering what is hypotenuse, like where did you get that from? That is always going to be your side that's opposite of the right angle. So if you look at that triangle that I have drawn at the top, see how I drew that black arrow? So the side right across from it is always going to be your hypotenuse. So it's leg squared plus leg squared is equal to hypotenuse squared, or what you guys have probably heard before is a squared plus b squared is equal to c squared. Alright, let's move on. Pythagorean triple. This is where you have three side lengths that form a right triangle, and all those side lengths are whole numbers. So I do want you guys to write down the examples 3, 4, 5, and 5, 12, 13. So if you do a Pythagorean theorem, you'll notice that they are right triangles. And then since all the numbers are whole numbers, that means that they're Pythagorean triples. So you know how we practice all those ACT problems? Well, those two examples that I wrote down for you, they come up all the time. And to save you time on the ACT, if you know the triangles 3, 4, 5 or 5, 12, 13, you'll be able to get through that problem really quick. So it's good to almost memorize those. Alright, let's move on. Let's try an example now. So number 1, it says find the length of the hypotenuse for each triangle. So again, here we have our triangle, and the side opposite of the right angle is our hypotenuse, so I'm going to label that x. Alright, so let's solve for this. So one of our legs would be 20 squared. So I'm going to write our equation up here again. A squared plus b squared is equal to c squared. So that just means our leg squared, which is 20 squared, plus our other leg squared, so our other leg is 21 squared, is equal to c squared, or in this case I wrote x. It doesn't matter, you could leave it as c squared or you could write x squared. I'm going to write x squared. So now let's solve this. 20 squared is going to be 400, and then 21 squared is going to be 441, and that's all equal to x squared. And then 400 plus 441 is going to be 841 is equal to x squared. Okay, this is kind of the tricky part. In order to get rid of the square, the x squared, just to get x, you have to take the square root. Square root and squared, they cancel each other. So then if I take the square root of 841, I'm going to get x is equal to 29. And that's it. Alright, let's try number 2 together. So let me draw in our right angle. And then the side opposite of our right angle is going to be our hypotenuse. So again, I'm going to label that x. So we're going to do leg squared plus leg squared is equal to hypotenuse squared. So one of our legs would be 8, so 8 squared plus one of our other legs squared, so 15 squared, is equal to x squared. So now let's solve that. 8 squared is going to be 64. Remember, 8 squared means 8 times 8, not 8 times 2. And then 15 squared, which is 15 times 15, is 225, which is equal to x squared. And then 64 plus 225 is 289. And then again, to get rid of the square root, or to get rid of the squared, we square root it. So take the square root of both sides. So if you do it to one side, you have to do it to the other side. And then x is equal to square root of 289 is going to be 17. And that is it. Alright, right now I want you guys to pause the video and then try number 3 and 4 on your own. And then check back to the video to see if you're right. Alright, number 3. So again, I drew a line from the right angle over to the hypotenuse so that we would know which one's the hypotenuse. And then we're going to do leg squared plus leg squared is equal to hypotenuse squared. So that would be 12 squared plus 35 squared is equal to x squared. And then 12 squared is going to be 144. And then 35 squared is 1,225. And then 144 plus 1,225 is going to be 1,369. And then to get rid of the squared, we're going to take the square root of both sides, and the square root is going to be 37. So x is equal to 37. Alright, let's try number 4. So the side across from the right angle is x, which is our hypotenuse. So again, we're going to do leg squared, 7 squared, plus our other leg squared, which is 9 squared, is equal to our hypotenuse squared, which is x squared. So 7 squared is 49, and 9 squared is 81. It's equal to x squared. 49 plus 81 is going to be 130. And then take the square root of both sides, and the square root of 130. I'm going to let you guys today write this as a decimal, and then tomorrow we're going to learn how to write it as a simplified radical. So for today, we're going to write as a decimal, so 11.4. Alright, good job you guys. Alright, let's look at the next problems. So right now we just found the hypotenuse, and these next problems we're going to have to find one of the legs. So this is a little bit more difficult. So let's try number 5. It says find the length of the leg for each triangle. So again, the side opposite of the right angle is going to be our hypotenuse, so that would be 20. So we're going to set up the same exact way. So one of our legs is x, so x squared plus 8 squared is equal to 20 squared. And then we're just going to simplify this. So 8 squared is going to be 64, and then 20 squared is 400. And then we still have our x squared on the left side. And then how do we get x squared by itself? We need to get rid of that 64 on both sides. So we're going to subtract 64 on both sides. And we have x squared is equal to 400 minus 64 is 336. And then just like before, the way that we get rid of the squared is we take the square root on both sides. So then x is equal to the square root of 336 is going to be a decimal again. So 18 point, I'm going to round it to the tenths place, so 18.3. Alright, I hope this is pretty easy for you guys. Let's look at the next problem, number 6. Alright, so first we want to identify the hypotenuse, so that's the side across from the right angle, so that would be 16. So we're going to set up Pythagorean Theorem, which is a squared plus b squared is equal to c squared. So one of our legs is going to be x, so x squared plus 10 squared is equal to our hypotenuse, which is 16 squared. Then we're going to write x squared plus 10 squared, which is 100, is equal to 16 squared, which is 256. So to get rid of the x squared, or to get everything away from the x squared, we're going to subtract 100 from both sides. And we're going to get x squared is equal to 156. And then to get rid of the squared, we're going to take the square root on both sides. And we get x is equal to, and rounding to the tenths place, we're going to get 12 point, and the 8's going to tell us to round up, so it's going to be 12.5. And that is our answer. So right now, I want you guys to try 7 and 8 on your own, and then watch the video to check your answer. Alright, let's move on to number 7. So again, the side across from the right angle is 6. So I'm going to do leg squared plus leg squared is equal to our hypotenuse squared. And our hypotenuse is 6, the one across from the right angle. So I'm going to do x squared plus 4 squared is equal to 6 squared. And then 4 squared is 4 times 4, which is 16. And 6 squared is 6 times 6, which is 36. To get the x squared by itself, I'm going to subtract 16 on both sides. And I'm going to get x squared is equal to 20. To get rid of the squared, our last step is to take the square root on both sides. And x is equal to 4 point, and then we're rounding to the tenths place, so 4.5. Alright, so go ahead and check your work. And then number 8. Alright, this one looks a little bit different than what we're used to seeing. So first find the hypotenuse. If I draw an arrow across from the right angle, do you guys see how 7 is the hypotenuse this time? Alright, so if we do side squared plus side squared is equal to hypotenuse squared, we're going to have x squared plus 4 squared is equal to 7 squared. So then if we simplify this, if we simplify this, what we're going to get is x squared plus 16 is equal to 49. Subtract 16 on both sides. And we get x squared is equal to 33. To get rid of the squared, we take the square root, and x is equal to square root of 33, which is 5.7. Alright, let's move on to some more difficult problems. These ones are word problems. Alright, so I'm going to read the question. It says, Jamal leans a 12-foot long ladder against the side of a house. The base of the ladder is 4 feet from the house. How high in the house does the ladder reach? So first thing, we have a 12-foot ladder, so I'm going to label all this. So this is 12-foot ladder in the purple right there. That's our ladder leaning against the house. And it says the base of the ladder is 4 feet from the house. So what that's trying to say is the base means the bottom. So this is 4 down here. And we're trying to find out how far up the house does the ladder reach. So this is going to be our x over here. We're trying to find out that side. So for this problem, we're looking for one of the legs, because if I draw an arrow across from the right angle, 12 is going to be our hypotenuse. So let's try this problem. Legs squared, so x squared, plus our other leg squared, which is 4 squared, is equal to our hypotenuse squared, which is 12 squared. So 4 squared is 16. And 12 squared is 144. To finish solving that, I'm going to subtract 16 from both sides. And 144 minus 16 is going to be 128, which is equal to x squared. And then to get rid of the squared, we take the square root of both sides. And x is equal to the square root of 128 is 11.3, and this is in feet, so 11.3 feet. So this one is very similar to the problems that we just did. Alright, let's look at our last problem. This one's about baseball. I hope we have some baseball fans out there. Alright, let me read the problem. So it says a baseball diamond is a square with sides of 90 feet. So right now, before we even continue, I'm going to start labeling our sides. So I'm going to take this problem and I'm going to break it up into pieces. So this is 90. This is 90, this is 90, and this side is 90. And it says, what is the distance running around the bases starting at first base and going to third base, and you have to touch second base? So let's assume that you hit the ball and you are already on first base. So I'm going to put a little star right there on first base. That's where you're standing. Now you need to go all the way around and touch second base and then third base. So this is actually going to be our short distance. So I'm going to write this in blue. So this is our short distance. And the way that we get that number by going around is we just add 90 plus 90. That's our total distance, which is 180 feet. So that's the first part of the problem. Now the second part says, what is the shortest distance from first base to third base? Now I know that if you guys know baseball, you guys know that we can't just run across the field and not touch the base. But we're going to assume for this problem that we're just going to run right across. We're going to cheat. Alright? So I'm going to draw a line from first right to third base. So that's our problem right now. We need to figure out how are we going to find out what this distance is. So second base is going to be considered our right angle. So across from our right angle is our x, because remember we're talking about a square, and so each one of the corners or bases is going to be a right angle. So now we just need to do Pythagorean Theorem. So our leg squared is going to be 90, so 90 squared plus our other leg, which is also 90 squared, is equal to our hypotenuse, which is x squared. So 90 squared is going to be 8,100 plus another 8,100 is equal to x squared. And then when we add those two together, we get 16,200 is equal to our x squared. And to get rid of the x squared, we're going to take the square root of both sides, which is going to give us x is equal to 127 point, I'm going to round it up to 0.3 feet. Alright, so that's our long distance. So this is our long distance. Or, I'm sorry. I have this messed up. The first one that we found was actually our long distance. And the one that we just found is obviously going to be our short distance because we just cut through. So then, it says how much shorter is cutting through the field from first to third base. So now we're going to take that long distance minus the short distance. So I'm going to do this in black in the corner right here. So we're just going to do 180 minus 127.3. And we would get 52.7. And this is in feet. So that's how much shorter it would be. Alright, so we're going to start at first base. And we're going to take the long distance from first to second to third. So our long distance is just going to be adding 90 plus 90. And that's going to equal 180. Alright, number 10. It says a baseball diamond is a square with sides of 90 feet. So right now, I'm going to go ahead and label the sides of the baseball diamond. Alright. It says, what is the distance running around the bases starting at first base and going to third base, touching second base? So that means you start out at home base, the pitcher threw you the ball, you hit it out in the outfield, and now you are starting at first base. So I'm going to put a little star there. Now they want you to touch second base and then go to third base. So let's find the distance taking that route. This is going to end up being the long route. We'll talk about the short route later, but the long route, we're going to do 90 feet plus 90 feet, which is 180 feet. Alright, let's look at the rest of the problem now. It says, what is the shortest distance from first to third base? Alright, I'm going to draw this in red so that you guys can see this. So I know in baseball you're not allowed to just cut through the baseball diamond, but that would technically be the shortest distance. So I'm going to draw a line from first to third base. That's how we're going to get to third base the fastest, is by cutting through the field. So in order to find this, at second base, we have a right angle right here. So across from second base is our hypotenuse. So we have to use Pythagorean Theorem, and this is going to be our short route. So we have one of our legs, which is 90, so 90 squared plus 90 squared, which is equal to our hypotenuse, and I'm going to label our hypotenuse x. That's what we're looking for. So x squared. Then 90 squared is 8,100, and we have two of those, and that's equal to x squared. And then we're going to add 8,100 plus 8,100, and we get 16,200, which is equal to x squared. To get rid of the squared, we take the square root of both sides, and our answer is x is equal to 127 point, round it to the tenths place would be 0.3 feet. So that would be the short distance. Then it asks how much shorter is cutting through the field from first to third base. So if we take the long route minus the short route, so I'm going to write this in the corner, the long route minus the short route. So we're going to take 180 minus 127.3. And when we do that, we get 52.7. So that's how much shorter it's going to be to take the shorter route. So 52.7 feet. Alright, right now I need you guys to start working on your homework. The homework is going to be tomorrow. Alright, have a good day.